This video will show operation of a Van Graaff mine ventilation network simulator with the model of the shearer cutting speed controller. So we can see the mine ventilation network scheme and initial moment of the simulation, in which the initial data has been loaded. Let's have a look at the screen to understand what can be seen here. The lines denote galleries. So here is the main gate, here is the Longwall, here is the tail gate. The arrows indicate the flow direction. Rectangles indicate the methane concentration in particular branches. The grid shows the groove adjacent to the Longwall. So we've got the target Longwall at which we will watch the controlled operation of the shearer, and this grid shows the groove of this Longwall, which are the voids which are left after the coal extraction. And above there is another abandoned Longwall, and we can see its groove, and we can see the distribution of the methane concentration. This Van Graaff model represents the mine ventilation network, represents the flow and gas propagation in the galleries, and also it has got an extra capability, which is the flow in porous media in the groove. And the groove is represented as a grid of perpendicular branches in which the flow is filtrational. So let's start our simulation. During this simulation, we will see the shearer which advances along the Longwall. Its current cutting speed will be shown in this graph, and in the graph below there will be the position of the shearer during the cut. So let's start the simulation. First, we will wait 9.5 minutes before the shearer starts cutting. The shearer operation is controlled by a sensor of methane which is placed close to the tailgate corner. So we can see increasing shearer cutting velocity. The shearer advances along the Longwall, and the level of methane concentration is rising. Therefore, the controller reduces the shearer's speed to prevent excessive methane buildup. So the concentration is still increasing, so the speed has to be even more reduced. As the concentration trend starts to stabilize, the changes of the cutting velocity are smaller, but the controller prevents the system from excessive methane concentration, maintaining it below the 2% limit. So we can see that the shearer is in the middle of the Longwall and is approaching its tailgate. However, due to the high methane concentration, its speed has been considerably reduced. This reduction prevents the system from the emergency power shutdown, which would occur if the methane concentration would exceed 2% limit. We can see small changes of methane concentration in the groove. It takes about 80 minutes for the whole cut along the long wall. Shearer is approaching the tailgate corner. As the concentration falls, the controller increases the cutting speed. And as the shearer reaches the end of a long wall, its speed is reduced to zero. This model doesn't represent the turnaround activities where the shearer prepares for its cut in the opposite direction, but it is assumed that all this operation lasts 15 minutes, and during this time the shearer cutting speed is set to zero. In a moment we will see shearer advancing towards the main gate, and as it advances it's got a negative value of the cutting speed, which due to the increase in methane concentration had to be reduced. So the shearer advances toward the middle of a long wall, and its cutting speed is changed accordingly to trends of the methane concentration of the shearer control sensor. The PID controller has been tuned so as to maintain this value within a safe limits. This simulation is performed on properly calibrated models. So first, the data for these models has been compared with field measurements and recording of the mine monitoring system to minimize the differences between measurements and simulation. Then such calibrated model is used during this demonstration. So we can see the second cut closest to its end. However, the cutting speed is relatively low due to high values of the methane concentration. Now the shearer has reached the main gate corner, and its cutting velocity will be reduced to zero, and we've got another 15 minutes break for the turnaround activities, and the shearer will start the next cut towards the tailgate. Here we can see increasing shearer cutting velocity. We can see how it advances toward the tailgate. We watch the methane concentration. We watch the effect of the controller on the shearer cutting speed. we can see that the controller prevents the methane concentration level from being higher than 2% limit. However, as we are close to this 2% limit, the shearer advance velocity has to be considerably reduced. For not controlled operation, we would have here several emergency power shutdowns, after which the whole longwall has to be ventilated and checked that the level of methane is reduced to permissible values, which causes a long break, reduction in production level. And also, if we compare the cumulative emission of methane in case of controlled and constant speed operation, we can see that this controlled release of methane is smaller than the one which occurs when we have emergency power breakdowns. So the third cut has finished, and this simulation will show a beginning of the cut number 4 after another turnaround phase. And we will, as the time of the working shift comes to the end, at the end of the simulation, the shearer will be stopped in the middle of a longwall. So we can see it starts advance towards the end of the main gate of a longwall. We can see the effect of the controller. And also we can watch the cumulative output of this mining shift in terms of tons of the coal. This value is being compared for both modes of operation, controlled and uncontrolled. So we come to the end of our demonstration. The shearer has stopped in the middle of the longwall due to the end of the shift. Thank you very much for your attention.